Here's problem 10.7. A bucket in an old well is hoisted upward by a rope which winds up on a cylinder having a radius of 0.05 meters. How many revolutions per second must the cylinder turn if the bucket is raised at a speed of 0.15 meters per second? So we have a bucket, and it's being hoisted up by a cylinder, and we know that the velocity we want on this bucket as it's being hoisted is 0.15 meters per second. But that will also have to be the velocity tangential on the cylinder for the cord. And if we have a radius on the cylinder equal to 0.05 meters, then we'll have associate with that an angular velocity in such a way that the linear velocity is equal to the angular velocity times the radius of that circle. That's our conversion from angular to linear in the form of velocity. So in this case, our angular velocity will equal the linear velocity we need divided by the radius of the circle. That is going to be 0.15 meters per second divided by 0.05 meters, which will be 3 radians per second. That's the angular velocity, but we want it in revolutions per second. So we're going to convert, knowing that there's 1 revolution for every 2 pi radians. So that is going to get rid of the radians, and that will give us revolutions per second. So 3 divided by 2 pi is 0.0478, or 0.478 revolutions per second. So if we turn the cylinder at 0.478 revolutions per second, the bucket will be raised at the velocity of 0.15 meters per second.